Okay, fine. Good evening, one and all. Now, I think in the previous class, we had the discussion concerned with the basic concepts of time response of feedback control systems. Now, in the previous class, I told you very specifically, now the entire response of feedback control system majorly has two distinct stages. One is the transient response and one more is steady state response. Now, what is the major difference between transient response and steady state response in the sense? Normally, if I try to make any changes, if I try to make any changes across the input, the changes what we make across the input, it gets reflected at the output after certain time. Why? Because certain time is required to have the changes from input side to the output side. Is that okay? And those things normally it is measured through transient response. Now, if I try to have some response, now just imagine this is the response of certain system. Now, this response has two stages. This is one stage and this is the other stage. Now, with this stage, we have the gain as constant. This is constant. And we have the variation in the gain from this portion to this portion. Is it okay? Now, this changes is not continuous, it is discontinuous. Why? Because if the changes what we make across the input, that it gets reflected at the output after some time. Is it fine? Now, how about the time is elapsed in the sense the time is indicated, like what are all the changes we shall make it at the input side, it gets reflected at the output only after certain time. And this response normally it is referred to as transient response. ಇದನ್ನು ಏನಂತ ಕರಿತೀವಿ ಟ್ರಾನ್ಸಿಯಂಟ್ ರೆಸ್ಪಾನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ನೋಡಿ ಇಲ್ಲಿ ಏನ್ ಚೇಂಜಸ್ ಮಾಡ್ತಿರ್ತೀವಿ ಇನ್ಪುಟ್ ಸೈಡ್ ಅಲ್ಲಿ that automatically it gets reflected at the output side. Is it okay? Where the gain is constant, this response is normally it is referred to as steady state. As it has reached the maximum value, thereby this is referred to as steady state, and this is transient state or transient response. As the name itself self-explanatory, transient is a region where like the what the output we expect with the maximum value that won't be attainable. Still, it is going to attain. Is it okay? Still, it will be under process. ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ? That is normally it is referred to as transient response. Whenever it reaches the maximum value or whenever it attains the attainable value, that is referred to as steady state value. Is it fine? Thereby, whenever if I try to calculate the overall output of any control system, it is evaluated by these two types of responses. That is the transient response and steady state response. Now, along with this, even we understood the standard test input signals. Now, majorly we have four types of input signals. What are those? Impulse input, step input, ramp input, and parabolic input. Right? What are all those? And those things we understood in the previous class. Now, coming to the summary. Now, majorly you need to memorize the Laplace transformation associated with this each of the inputs for unit impulse function. That is unit impulse function delta of t. What is the Laplace associated with that is 1. Now, what is the unit step input? Unit step input is u of t, which is equal to 1 for t greater than or equal to 0. How about the corresponding Laplace? 1 by s. How about for unit ramp input? It is t for t greater than or equal to 0, and the corresponding Laplace is 1 by s. Right? Similarly, if I try to have this unit parabolic input, now how do we designate this unit parabolic input? T square by 2, and the corresponding Laplace is 1 by s cube. And this you need to memorize it clearly. And next, in the previous class, we had the discussion concerned with this time response analysis of first order system. That I told you very clearly. This order of the system, majorly we decided based on the denominator part of the transfer function. Now you can have a look. With this transfer function, this is open loop transfer function, and this C of S by R of S is the entire transfer function, that is closed loop transfer function. Now with this closed loop transfer function, you can have a look. C of S by R of S is 1 divided by Ts plus 1. Is it okay? Since we have only S, that is the first order, the power of S is 1. Thereby, this is normally referred to as first order system. If the power of S is 2, it is referred to as second order system. If the power of S is 3, it is referred to as third order system. And if the power of S is 4, it is referred to as fourth order system. Is it okay? This is how we'll identify the order of the system based on the denominator part of the transfer function, and that too we'll strictly concentrate with the power of s. Is it okay? Now, if I try to have the first order system with the open loop transfer function as 1 by Ts, now what will be the overall closed loop transfer function? 1 divided by Ts plus 1, right? Now, this system has only one pole. Now, where does that pole it lies? Ts plus 1 is equal to 0, or Ts is equal to minus 1, S is equal to minus 1 by T, and this normally T is referred to as time constant of a system. Now, what is our agenda? Now, our agenda is to find the unit step response of this first order system. Now, this is the first order system, CFS by RFS, 1 by Ts plus 1. Is it okay? Now, if I try to, our interest is to have the response. Response is nothing but the output. In order to find this output, I shall cross multiply this RFS to the transfer function. Thereby, what is this? It becomes CFS is equal to 1 by Ts plus 1 into RFS. What is RFS? RFS is the Laplace transformation of unit step input. Why? Because we are interested in finding the time response of a system for unit step input. Nodi ಈಗ 4 inputs ನ apply ಮಾಡಬಹುದು. Step input, ramp input, parabolic input ಮತ್ತೆ delta input. That is impulse input. But in our like syllabus, we need to concentrate with the unit step input. Why? Because the most of the applications what we come across, the entire analysis is based on unit step input. Is it fine? Now, what is the value of R of S? R of S is 1 by S, right? Next, what is C of S? C of S is 1 by Ts plus 1 into 1 by S. Is it okay? Now, I require the response in time domain. Since I require the response in time domain, what I shall make? I need to convert this multiplication into sum, or I shall convert this product to sum. When we have the flexibility of converting product to sum, I need to go for partial fraction approach. For using partial fraction approach, how about the condition to be satisfied? The condition is the order of the numerator should be less than the order of the denominator. You can have a look. What is the order of the numerator? The order of the numerator. Now, the order of the numerator is zeroth order, wherein the order of the denominator is first order. The condition has been satisfied. Is it okay? Thereby, I shall further simplify it as A. Normally, even this thing's partial fraction approach you have studied in your 10 plus 1 and 10 plus 2. That is first PU and second PU when you learn that infinite power series in mathematics, right? Now with this, I can able to evaluate the constant values of A0 and A1 through this relation. How do I write this? First, one term has A0 by S, that I can write it as A0 by S plus A1 divided by Ts plus 1. ಈಗ ನಾನು A0 ಮತ್ತೆ A1 ಅನ್ನ evaluate ಮಾಡಬೇಕು. How do I evaluate this A0 and A1? The evaluation of A0 and A1 is quite simple. Now I need to eliminate this S. To find the value of A0, I need to eliminate the value of S within the overall transfer function. What is the overall transfer function? 1 divided by Ts plus 1. This is Ts plus 1 into 1 by S. Is it okay? Right? This is the entire transfer function. From this, I need to evaluate this S. Now, if I try to evaluate this S and the existence of this S, it will be at S is equal to 0. Ekendre, ನಾನು previous term ತೋರಿಸಿದೆ. How do I evaluate the roots? Always roots will be evaluated by equating the value to this 0. Right? Thereby, first I shall equate after simplifying this. Now, where does this S it gets existed? Only at S is equal to 0. Right? Now, based on that, what is the value of A0? A0 is 1 divided by Ts plus 1 at S is equal to 0. Now, if I try to put S is equal to 0, now what is left out? 1. Similarly, I shall find A1. To find A1, ಇಲ್ಲಿ S multiply ಮಾಡಬಾರ್ದು. What I shall multiply? Ts plus 1. Is that okay? Now, if I try to multiply this Ts plus 1, so that I may able to cancel this Ts plus 1 and Ts plus 1. What is left out? Only S is left out. Is it okay? In the previous instance, we multiplied by S. In the current instance, the term is Ts plus 1. Thereby, I shall multiply by Ts plus 1. Now, where does this Ts plus 1 it gets existed? At Ts plus 1 is equal to 0. ನೋಡಿ ಇದನ್ನ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಅಲ್ಲಿ next discussion is there, which is very important. Avaga nimage confusion barbardo. Thereby this you need to understand it very specifically. Ts plus 1 is equal to 0 or Ts is equal to minus 1. Now, how about the value of S? S is equal to minus 1 by T. Is it okay? Thereby, what? How about the value of A1? 1 by S at S is equal to minus 1 by T. You can have a look. Just now I had shown this. Now, after simplifying, what do I get? The value of A1 is minus T. Later, I'll substitute this. We have converted product to sum using Laplace transform, using partial fraction approach. Next, what is A0? A0 is 1, thereby 1 by S minus, what is A1? Minus T. Actually, this is plus. Because of this minus T, it becomes minus T divided by T into S plus 1 by T. You'll notice TS plus 1 ಏನಿದೆ ಅಲ್ಲಿ T common ತಗೊಂಡಿದ್ದೀವಿ to have the simplification, further simplification. ಇಲ್ಲಿ T common ತಗೊಂಡ್ರೆ ಏನು ಬರುತ್ತೆ S plus 1 by T, so that I may cancel this T and T with this. Now after cancellation of this T and T, what is left out? 1 by S minus 1 divided by S plus 1 by T. Actually, we won't expect output. ನಮಗೆ ರೆಸ್ಪಾನ್ಸ್ ಬೇಕು. ರೆಸ್ಪಾನ್ಸ್ ಬೇಕು ಅಂದ್ರೆ ಇದು ಲ್ಯಾಪ್ಲೇಸ್ ಡೊಮೈನ್ ಅಲ್ಲಿ ಇದೆ. Normally, we won't expect response in Laplace domain. Like, how do we expect? We expect in time domain. Thereby, I shall convert this Laplace domain to time domain. Thereby, I need to go for inverse Laplace transform. Now, if I try to take inverse Laplace transform for this, what is the inverse of 1 by S? The inverse of 1 by S is 1. Why? Because like Laplace transformation of 1 is 1 by S, unit step input, right? Now, this is of the form 1 divided by S plus A. When we have, this is the standard Laplace relation. When we have 1 divided by S plus A, what will be the Laplace of this? Like this is 1 divided by S plus A. Now, what is the inverse of it? The inverse of this is e power minus 80. Or what is the inverse of e power minus 80? This is 1 divided by S plus A. If A value in there, what is the value of A? 1 by T. That you can have a look. If I try to have inverse, 1 minus e power minus 80. Is it okay? Now, what is A? A is nothing but 1 by 2. Now, this is the overall response what we have obtained for this first order system with the transfer function 1 divided by Ts plus 1, and we applied the input as unit step input, that is U of T. Is it okay? Right? With the value of R of S is equal to 1 by S, and we simplified. Now, what the output we have obtained? The output we have obtained it as C of T is equal to 1 minus e to the power of minus T divided by T. Now, the same thing has been plotted. You need not to worry about steady state error. Why? Because steady state error is not at all included in the syllabus. Thereby, I'll try to skip this. I won't discuss anything about the steady state error. Now, directly I'll move on to the frequency response. Now, this response has been plotted based on the value of T. Now, T has been started varying from 0. Is it okay? And it has been varied to certain finite duration. ಇದನ್ನ ಹೇಗೆ ವೆರಿ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಫಸ್ಟ್ ಇನಿಷಿಯಲಿ 0 ಆದಾಗ ಇಲ್ಲಿ ಟಿ 0 ಆಗ್ತಾ 0 ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಇ ಟು ದ ಪವರ್ ಆಫ್ 0. ವಾಟ್ ಇಸ್ ಇ ಟು ದ ಪವರ್ ಆಫ್ 0? ಇ ಟು ದ ಪವರ್ ಆಫ್ 0 ಇಸ್ 1. ದೇರ್ ಬೈ 1 minus 1 is 0. ನೋಡಿ ಅಟ್ 0 ಅಲ್ಲಿ ಏನಿದೆ 0 ಇದೆ. ಆಮೇಲೆ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ನೀವು ಟಿ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. My point is clear. Later I shall substitute the value of t. Now, if I try to substitute the value of t, what do I get? Next, if first to t is equal to 0, next I will go for small t is equal to 1 by t, next 2 by t, 3 by t, so on. ಅವಾಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದ್ದಾಗ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ. ಇಸ್ ಇಟ್ ಓಕೆ? ಇಲ್ಲಿ ನೋಡಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ. ಆಮೇಲೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. Right? Now, this has two things. This portion is referred to as transient response, and this portion is referred to as steady state response. You can have a look. This has been clearly indicated. This is the response due to this e power minus t divided by t. And this one is the steady state value. Nodi? One is the constant in the steady state value. This 1 minus, this is e power minus t by t. ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ ನೋಡಿ, ಈ ರೀತಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ ಮತ್ತೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಇದನ್ನ ನಾವು ಸ್ಟಡಿ ಸ್ಟೇಟ್ ವ್ಯಾಲ್ಯೂ ಅಂತ ಕರಿತೀವಿ. ನಾವು ದ ಟೋಟಲ್ ಔಟ್ಪುಟ್ ಇಸ್ 1 minus e to the power of minus t divided by t. ಇಲ್ಲಿ ಸಮ್ ಆಫ್ ಟೂ ರೆಸ್ಪಾನ್ಸಸ್ ಇದೆ. ಇದು ಟ್ರಾನ್ಸಿಯಂಟ್ ರೆಸ್ಪಾನ್ಸ್, ಇದು ಸ್ಟಡಿ ಸ್ಟೇಟ್ ರೆಸ್ಪಾನ್ಸ್. The total of these two is our TFT. That is the total response. Did you get my point? And this is the output what we expect for first order system, right? Now this is associated with the first order system. Later I will be concentrating with the second order system. 1 second, I'll try to stop this. Next, if I go for second order system, now how about the slides? Are they visible?
No, sir.
Nobody try to play. Visible ಇದೆಯಾ? ಸ್ಲೈಡ್ಸ್ ಶೇರ್ ಆಗ್ತಾ ಇದೆಯಾ?
No, sir.
No,
ಆಯ್ತಲ್ಲ.
ಇಲ್ಲ, ಓಕೆ, ಶೇರ್ ಮಾಡ್ತೀನಿ. 1 second. I think now it is visible, right?
Visible.
Yes, sir.
Okay, fine, guys. The extended portion or the extended topic. First, we understood in the first session the in the first session, we understood the basic concepts. What is transient response? What is steady state response? What are all the different kinds of standard inputs available? Then also we learned time response analysis for first order system with respect to unit step input. Is it okay? That we understood. Now the same thing I'll move out or I'll carry forward with the second order system. Is it okay? If first order system the same thing we need to understand it for the second order system. Now what is the agenda of the discussion? We shall have two things: second order system, then unit step response of second order system for different cases. Is it okay? Now if I try to have the second order system, you can have a look. Ali first order, like the previous session only, what we understood was concerned with the first order. Is it okay? Now for first order, what was the transfer function we considered? 1 divided by ts plus 1. Is the first order. Now I need to concentrate with the second order. Second order, yeah, we have standard transfer function. What is that? This is the standard transfer function for second order. Omega n square divided by s square plus 2 xi omega ns plus omega n square. This is the second order transfer function. You please try to memorize this. Omega n square divided by s square plus 2 xi omega ns plus omega n square. This is the second order transfer function. ಇದು ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಅಂತ ಯಾಕೆ ಕರಿತೀವಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ಡಿನೋಮಿನೇಟರ್ ಪಾಲಿನಾಮಿಯಲ್ what is the order of the s? It is second order, thereby it is referred to as second order transfer function. Now this is open loop transfer function, OLTF. That is the value of g of s. Now how about the value of g of s? Omega n square divided by s into s plus 2 xi omega n. ನನ್ನ voice clear ಇದೆ ಅಲ್ಲ? I don't think you have any disturbance, right?
Okay, sir. Clear ಆಗಿದೆ.
Okay, fine. And if you found, if you find any other disturbances, you please try to ping me in the group.
Okay, sir.
Now, this is open loop transfer function g of s. ಇಲ್ಲಿ ಟೋಟಲ್ ಕ್ಲೋಸ್ ಲೂಪ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್ ಇದೆ. ಇದರಲ್ಲಿ ನಾನು ಓಪನ್ ಲೂಪ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್ ಮಾತ್ರ ಬೇಕು ಅಂದ್ರೆ how about that open loop transfer function g of s? Normally it is denoted by omega n squared divided by s into s plus 2 xi omega n. These relations you need to memorize it. Why? Because we shall have the same thing when we work out problems. That is the application part. Now coming to this. Now how about the closed loop transfer function for second order system C of s by R of s, which is given by g divided by 1 plus g into h. You know, h ಏನಿದೆ ಇಲ್ಲಿ unity feedback system. H of s is 1. Right? Now the same thing has been substituted over here. G of s. Omega n square divided by s into s plus 2 xi omega n divided by 1 plus g is omega n square divided by s into s plus 2 xi omega n into 1. Right? Now after simplification, we shall have this closed loop transfer function as such omega n square divided by s square plus 2 xi omega ns plus omega n square. Is it okay? Now, with this transfer function, normally omega n is referred to as undamped natural frequency of oscillation. What is omega n? Omega n is undamped natural frequency. Now, what is damped natural frequency and undamped natural frequency? Now, what are the xi damping factor it indicates? Furthermore details I'll try to explain in the next slide. Is it okay? For time being, you please try to remember. Normally, omega n is referred to as undamped natural frequency, and xi is nothing but damping ratio or damping factor. ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ? Xi ಅಂತ ಕರಿತೀವಿ ನೋಡಿ, ಇಲ್ಲಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. We have this term. Is it okay? 2 xi omega ns. What is this xi? Xi is nothing but damping factor or damping ratio. Omega n is nothing but undamped natural frequency. Now, what are all these things? You can have a look. From this slide, we have two figures. This is oscillation. This is one kind of oscillation. This is the other kind of oscillation. ಇಲ್ಲಿ ನೋಡಿ, ಈ ಆಸಿಲೇಷನ್ ಅಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟ್ ಲೈಕ್ ಸೈನ್ ವೇವ್ ಕ್ಲಿಯರ್ ಆಗಿ ವೇರಿ ಆಗ್ತಾ ಇದೆ. ಹೌದಾ? ಇಸ್ ಇಟ್ ಓಕೆ? ಅಂಡ್ ದೇರ್ ಇಸ್ ನೋ ಡ್ಯಾಂಪಿಂಗ್. ಅಂದ್ರೆ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಏನು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇಲ್ಲ ಈ ಕೇಸಲ್ಲಿ, ಅನ್ಡ್ಯಾಂಪಡ್ ಕೇಸಲ್ಲಿ. ಬಟ್ ಇಲ್ಲಿ ನೋಡಿ, ಈ ಕೇಸಲ್ಲಿ ನೋಡಿ, ಫಸ್ಟ್ ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದೆ, ಆಮೇಲೆ ಇಲ್ಲಿ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಏನಾಗ್ತಾ ಇದೆ? ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆಯಾ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆಯಾ? ಇದು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಈ ರೀತಿ ಡಿಕ್ರೀಸ್ ಆಗೋದಕ್ಕೆ ನಾವ್ ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ, ದಿಸ್ ಆರ್ ಆಲ್ ದ ಡ್ಯಾಂಪ್ಡ್ ಆಸಿಲೇಷನ್. ವಾಟ್ ಆರ್ ಆಲ್ ದಿಸ್? ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಏನಾದ್ರೂ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತಾ ಇದ್ರೆ ಆ ಆಸಿಲೇಷನ್ಸ್ ನ ಏನಂತ ಕರಿತೀವಿ ನಾವು? ಡ್ಯಾಂಪ್ಡ್ ಆಸಿಲೇಷನ್ಸ್. ಇಲ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಹಾಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ನಾರ್ಮಲ್ ಆಗಿ ವೇರಿ ಆಗ್ತಾ ಇದ್ರೆ ಇದನ್ನ ಅನ್ಡ್ಯಾಂಪ್ಡ್ ಆಸಿಲೇಷನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ನೋಡಿ, ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಎ ಲುಕ್. ದಿಸ್ ಇಸ್ ಅನ್ಡ್ಯಾಂಪ್ಡ್ ಆಸಿಲೇಷನ್. For undamped oscillation, xi is always equal to 0. Second order system alli, we won't expect undamped oscillations. We always expect damped oscillations. This parameter you need to understand it clearly. Why? Because in the second order transfer function itself, we have the presence of xi. Now, because of the presence of the xi, it is damping ratio or damping factor. This damping factor or damping ratio, what does it does in the sense? It makes the oscillations clearly nullified or it reduces the oscillations to lower level. Thereby, ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ನೋಡಿ, undamped ಕೇಸ್ ಅಲ್ಲಿ xi 0 ಇರುತ್ತೆ. Is it fine? xi ಎಲ್ಲಿ 0 ಇರಲ್ಲ ಅಲ್ಲಿ ನಾವು ಏನ್ ಅಂತ ಕರಿತೀವಿ ನಾವು, this case xi is not equal to 0. My point is clear. When xi is not equal to 0, these oscillations are referred to as damped oscillations. ಈ damped oscillations ಅಲ್ಲಿ we have three distinct cases. ಅಂಡರ್ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸ್ ಬರುತ್ತೆ, ಕ್ರಿಟಿಕಲಿ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸ್ ಬರುತ್ತೆ, ಮತ್ತು ಓವರ್ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸ್ ಬರುತ್ತೆ. ಈಗ ಅಂಡರ್ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸ್, ಲೈಕ್ ವೆನ್ ಡು ವಿ ರೆಫರ್ ದಿಸ್ ಅಂಡರ್ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸ್? ಇನ್ ದ ಸೆನ್ಸ್ when xi value less than 1. When xi value less than 1, it is referred to as under damped case. This is very important. Under damped case is very important. Is it okay? When xi is equal to 1, it is critically damped case. When xi greater than 1, it is referred to as over damped case. ಇಲ್ಲಿ ನೋಡಿ, ಮೂರನ್ನು ಪ್ಲಾಟ್ ಮಾಡಿದೀವಿ. ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಟಾಪ್ ಏನ್ ಬರ್ತಾ ಇದೆ? ದಿಸ್ ಇಸ್ ಅಂಡರ್ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸ್. ಫಸ್ಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ಅದು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಕ್ರಿಟಿಕಲಿ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸ್ ಅಲ್ಲಿ ನೋಡಿ, ಇದು ಆಕ್ಚುಲಿ ಪ್ಯಾರಾಬೋಲಿಕ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. ಇದು ಕರ್ವ್ ಇದ್ದು ಆಮೇಲೆ ಆಸಿಲೇಷನ್ಸ್ ಬರ್ತಾ ಇದೆ. ಇದು ಹೇಗಿದೆ? ಲೀನಿಯರ್ ಲೈನ್ ಇದೆ. Is it not this? Linear line for critically damped case. That is when xi is equal to 1. Over damped case nodi, still linear line. Is it okay? Then we have the oscillation. Right? Now, with this second order transfer function C of s by R of s, is it okay? The denominator part is referred to as characteristic polynomial. ಇದನ್ನ ಏನಂತ ಕರೀತೀವಿ? This is referred to as characteristic polynomial. ಇದನ್ನ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಪಾಲಿನಾಮಿಯಲ್ ಎಲ್ಲ ಬೇಕು. ನೆಕ್ಸ್ಟ್ ನಾನು RH ಕ್ರೈಟೀರಿಯನ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಪಾಲಿನಾಮಿಯಲ್ ಏನು ಅಂತ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಲೈಕ್ ಫರ್ದರ್ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಗಲ್ಲ. Thereby this you need to understand it very clearly. If I try to have any second order system, the denominator polynomial is referred to as characteristic polynomial, and this entire equation is referred to as characteristic equation. Now this is characteristic polynomial. When this polynomial is equated to 0, the resulting equation is nothing but the characteristic equation. How about the characteristic equation? 1 plus g of s into h of s is equal to 0. Ekandre, this is the total characteristic equation. 1 plus g of s into h of s is equal to 0. ಸರಿ ಇದೆಯಾ? Denominator part of the closed loop transfer function is referred to as like characteristic equation, which is of the form 1 plus g of s into h of s. ಆ characteristic equation roots ಏನ್ ಬರುತ್ತೆ ಅದನ್ನ ನಾವು polynomial ಅಂತ ಕರಿತೀವಿ. Right? Now we'll understand these three cases. We'll understand the possibility of the roots for these three cases: under damped case, critically damped case, and over damped case. Now we can have a look. ಈಗ ನಾನು characteristic equation ತಗೊಂಡ್ರೆ, now what is the characteristic equation of the second order system? A standard equation ಅಲ್ಲಿ s square plus 2 xi omega ns plus omega n square. ಇಲ್ಲಿ second order ಆಗಿರೋದ್ರಿಂದ I shall find the roots of this. The two roots of the characteristic equation are given by, now ಇದನ್ನ ನಾನು ಡೈರೆಕ್ಟ್ ಫ್ಯಾಕ್ಟರೈಸ್ ಮಾಡೋದಕ್ಕಾಗಲ್ಲ. ಇವಾಗ ನಾನು ಶ್ರೀಧರಾಸ್ ರಿಲೇಷನ್ ನ ಯೂಸ್ ಮಾಡಬೇಕು. s1, s2 is equal to minus b. I think this is what you have learnt in your lower classes, 10th standard. Minus b plus or minus square root of b square minus 4ac divided by 2a. Is it okay? Now this is the relation what I shall use to find the roots of this characteristic equation. Is it okay? Now if I try to use this, how about the roots I shall have? This is of the form ax square plus bx plus c. What is a? A is 1. What is b? 2 xi omega n. What is c? C is also 1. You know, substitute ಮಾಡಿದ್ರೆ what is b? Minus b ಆಯ್ತು ಅಂದ್ರೆ it is minus 2 xi omega n plus or minus square root of b square. 2 xi omega n whole square ಆದ್ರೆ 4 xi square omega n square minus 4. Is it okay? 4 omega n square. B square minus 4a into 6. What is c? C is omega n square. Is it okay? Right? Next is then simplify ಮಾಡಿದ್ರೆ, now what do we have? After simplification, like this is minus xi omega n plus or minus, ಇಲ್ಲಿ 2 outside ಬರುತ್ತೆ, square root ತಗೊಂಡ್ರೆ, ಇಲ್ಲಿ 4 ನಾನು ಕಾಮನ್ ತಗೊಂಡ್ರೆ square root of 4 is 2. ಅವಾಗ I may cancel this 2 and 2. Is it okay? Now what is left out? ಇಲ್ಲಿ omega n square ಇದೆ. ಇದನ್ನ ನಾನು ಹೊರಗಡೆ ತಗೊಂಡ್ರೆ ಅದು omega n ಆಗುತ್ತೆ. omega n as it is ನಾನು ಇಟ್ಕೊಂಡಿದ್ದೀನಿ. Like into square root of xi square minus 1. ಇಲ್ಲಿ ನೋಡಿ 2 roots ಇದೆ, ಒಂದು ಪ್ಲಸ್ ಇನ್ನೊಂದು ಮೈನಸ್. Is it okay? Right? Now first case, what is first case? When xi less than 1. ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ? Under damped case. Now what are all the roots of the characteristic equation? For under damped case ಅಲ್ಲಿ ನೋಡಿ, ಈ xi value less than 1 ಆದಾಗ ಇದು ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, ಹೌದಾ? ಇದು ಲೆಸ್ ದ್ಯಾನ್ 1 ಆಯ್ತು ಅಂದ್ರೆ 0.5 0.7 ಏನೋ ಬರುತ್ತೆ. ಈಗ 0.7 minus 1 ಮಾಡಿದ್ರೆ ಲೈಕ್ ವ್ಯಾಲ್ಯೂ ನೆಗೆಟಿವ್ ಬರುತ್ತಾ ಪಾಸಿಟಿವ್ ಬರುತ್ತಾ? ಇಟ್ ಬಿಕಮ್ಸ್ ನೆಗೆಟಿವ್. ನೆಗೆಟಿವ್ ಆದಾಗ ಈ ಟರ್ಮ್ ಏನಾಗುತ್ತೆ? ದಿಸ್ ಇಟ್ ಬಿಕಮ್ಸ್ 0. Thereby the roots what we expect or the roots what we obtain for under damped case is always imaginary. That you can have a look. Nodi, the system is said to be under damped. The roots of the characteristic equation are given by s1, s2 is equal to minus xi omega n plus or minus omega n into square root of xi square minus 1 ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. ಆಕ್ಚುಲಿ ಇಲ್ಲಿ ಏನಿದೆ? xi square minus 1 ಇದೆ. ಈಗ ನಾನು xi square minus 1 ಬರ್ಕೊಂಡ್ರೆ ಇದು ಕಡಿಮೆ ಇರೋದ್ರಿಂದ 1ಕ್ಕಿಂತ ರೂಟ್ ಏನಾಗುತ್ತೆ? ಇಮ್ಯಾಜಿನರಿ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ? ಇದನ್ನ ರಿವರ್ಸ್ ಬರ್ಕೊಂತೀನಿ. ಮೈನಸ್ xi omega n ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಈ ಜೇನ ಹೊರಗಡೆ ತಗೊಂಡು ಒಮೆಗಾ ಎನ್ ಇಂಟು ರೂಟ್ ಆಫ್ 1 ಮೈನಸ್ xi. ಇಲ್ಲಿ xi ಮೈನಸ್ 1 ಬರೆಯೋ ಬದಲು ನಾನು ಇದನ್ನ ಏನಂತ ಬರೀತೀನಿ? 1 ಮೈನಸ್ xi ಸ್ಕ್ವೇರ್ ಅಂತ ಬರ್ಕೋಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ? ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಒಮೆಗಾ ಎನ್ ಇಂಟು ಒಮೆಗಾ ಡಿ, ಒಮೆಗಾ ಎನ್ ಇಂಟು ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 1 ಮೈನಸ್ xi ಸ್ಕ್ವೇರ್ ಇಸ್ ರೆಫರ್ ಟು ಆಸ್ ಡ್ಯಾಂಪ್ಡ್ ನ್ಯಾಚುರಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಯಾಕೆಂದ್ರೆ ಡ್ಯಾಂಪಿಂಗ್ ಆಗ್ತಾ ಇದೆ. Is it okay? How do I indicate the damping value? Damping value is indicated by this omega suffix d. That is omega n into root of 1 minus xi square. Is it okay? Now, how about the nature of the roots for under damped case? The roots are imaginary. ನೋಡಿ, ಇದನ್ನ ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು. Like damped natural frequency. Second case ಹೋಗೋಣ. When the system is said to be critically damped. How about the roots of the characteristic equation? ನೋಡಿ, ಇಲ್ಲಿ xi value 1 ಆಗುತ್ತೆ. xi value 1 ಆದಾಗ 1 minus 1 is 0. That means this entire thing it goes to 0. ಇಲ್ಲಿ xi value 1 ಆದಾಗ this is 1. Is it okay? Now how about the roots we expect? The roots are real and equal. Minus xi, sorry, ಮೈನಸ್ ಒಮೆಗಾ ಎನ್ ಮೈನಸ್ ಒಮೆಗಾ ಎನ್. ಇದು ಯಾವ ಕೇಸಲ್ಲಿ? ಕ್ರಿಟಿಕಲಿ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸಲ್ಲಿ. ಅದೇ ರೀತಿ ನಾನು ಓವರ್ ಡ್ಯಾಂಪ್ಡ್ ಕೇಸ್ ಹೋದಾಗ ಹೌ ಅಬೌಟ್ ದ ಟೂ ರೂಟ್ಸ್? ನಾವು ಲೈಕ್ ಹೌ ಅಬೌಟ್ ದ ಥಿಂಗ್ ಮೈನಸ್ ಝೈ ಒಮೆಗಾ ಎನ್ ಪ್ಲಸ್ square root of xi square minus 1 into omega n. In this case, the roots are real and distinct. ಯಾಕೆಂದ್ರೆ xi value greater than 1 ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 2 ತಗೊಂಡ್ರೆ 2 minus 1, what do I get? 1, which is real. Is it okay? Right? Previous case ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇತ್ತು? Under damped case ಅಲ್ಲಿ the roots were imaginary. The roots are real and distinct for over damped. Is it fine? Next, how about the fourth case? Like if you want, I shall have one more case. That is the fourth case. That is undamped case. Undamped case ಅಲ್ಲಿ xi value ಬರೋದೇ ಇಲ್ಲ. ಅವಾಗ roots ಏನಾಗುತ್ತೆ? Plus or minus j omega n. That means we have two roots that are complex conjugate with zero real value. But we won't concentrate much on this underdamped case. We will be concentrating with these three cases. Undamped case ನಾವು ಅಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಲ್ಲ. ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡೋದು ಯಾವ್ದ್ರ ಬಗ್ಗೆ ಅಂದ್ರೆ ಅಂಡರ್ ಡ್ಯಾಂಪಡ್ ಕೇಸ್, ಲೈಕ್ ಕ್ರಿಟಿಕಲಿ ಡ್ಯಾಂಪಡ್ ಕೇಸ್ ಅಂಡ್ ಓವರ್ ಡ್ಯಾಂಪಡ್ ಕೇಸ್. ಇಸ್ ಇಟ್ ಓಕೆ? ಆಕ್ಚುಲಿ ಮೂರಕ್ಕೂ ಡೆರಿವೇಶನ್ ಇದೆ, ಬಟ್ ಐ ವಿಲ್ ಬಿ ಎಕ್ಸ್ಪ್ಲೈನಿಂಗ್ ಓನ್ಲಿ ಅಂಡರ್ ಡ್ಯಾಂಪಡ್ ಕೇಸ್ ವಿಚ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ರಮ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ಎಕ್ಸಾಮಿನೇಷನ್. ಬಟ್ ನಾನು ಏನ್ ಮೆಟೀರಿಯಲ್ ಕೊಡ್ತೀನಿ ನೋಟ್ಸ್, ಅದರಲ್ಲಿ ಮೂರ್ದು ಡೆರಿವೇಶನ್ ಇದೆ. ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಎ ಲುಕ್. Is it okay? Next comes very important aspect, that is to understand the time response analysis of second order system for unit step in. ಈಗ ನಾವು ಫಸ್ಟ್ ಆರ್ಡರ್ ಏನ್ ಮಾಡಿದ್ವಿ, ಸಿಮಿಲರ್ ಕೈಂಡ್ ಆಫ್ ಪ್ರೊಸೀಜರ್ ನಾನು ಫಾಲೋ ಮಾಡಬೇಕು. ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ, ಫಸ್ಟ್ ನಾವು ವಿ ಕನ್ಸಿಡರ್ ದ ಕ್ಲೋಸ್ ಲೂಪ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್ ಆಫ್ ದ ಫಸ್ಟ್ ಆರ್ಡರ್ ಸಿಸ್ಟಮ್. ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಸಿಸ್ಟಮ್ ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ, ಹೌ ಅಬೌಟ್ ದ ಕ್ಲೋಸ್ ಲೂಪ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್ ಆಫ್ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಸಿಸ್ಟಮ್? Omega n square divided by h square plus 2 xi omega ns plus omega n square. Will you agree? Is it okay? Next ನನಗೆ ಆಕ್ಚುಲಿ ಏನ್ ಬೇಕು? ರೆಸ್ಪಾನ್ಸ್ ಬೇಕು. ರೆಸ್ಪಾನ್ಸ್ ಅಂದ್ರೆ ಸಿ ಆಫ್ ಎಸ್. ಅವಾಗ ನಾ ಏನ್ ಮಾಡಬೇಕು? ಆರ್ ಆಫ್ ಎಸ್ ಐ ಶಲ್ ಮಲ್ಟಿಪ್ಲೈ ಟು ನ್ಯೂಮರೇಟರ್, ದೇರ್ ಬೈ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್. ಅವಾಗ ಏನಾಗುತ್ತೆ? ಸಿ ಆಫ್ ಎಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಒಮೆಗಾ ಎನ್ ಸ್ಕ್ವೇರ್ ಇಂಟು ಆರ್ ಆಫ್ ಎಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2 xi omega ns plus omega n square. ಅವಾಗ ಆರ್ ಆಫ್ ಎಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತದೆ? 1 by s for unit step inch. Is it okay? ಅವಾಗ ನೋಡಿ, this is one separator, this is one separator. ಅಲ್ಲಿ one ಫಸ್ಟ್ ಆರ್ಡರ್ ಏನಿತ್ತು? 1 divided by ts plus 1. ನೋಡಿ ಅದನ್ನ ರೀಕಾಲ್ ಮಾಡಿ. 1 divided by ts plus 1 into 1 by s ಅಂತ ಇತ್ತು. ಹೌದಾ? ಯಾವ ಕೇಸಲ್ಲಿ? ಫಸ್ಟ್ ಆರ್ಡರ್ ಕೇಸಲ್ಲಿ. ಈಗ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಕೇಸಲ್ಲಿ ಇದು ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಟ್ರಾನ್ಸ್ಫರ್ ಫಂಕ್ಷನ್ ಬಂದಿದೆ. ದಟ್ ಇಸ್ ಒಮೆಗಾ ಎನ್ ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2 xi omega ns ಪ್ಲಸ್ ಒಮೆಗಾ ಎನ್ ಸ್ಕ್ವೇರ್ ಇಂಟು 1 by s. ನೋಡಿ, ಅಲ್ಲಿ ಫಸ್ಟ್ ಆರ್ಡರ್ ಕೇಸ್ ಅಲ್ಲಿ ಇಟ್ ವಾಸ್ ಕ್ವೈಟ್ ಸಿಂಪಲ್. ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಬಂದಿದೆ. ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಅಲ್ಲಿ ಇದು ಆಕ್ಚುಲಿ ನಾನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಫ್ಯಾಕ್ಟರೈಸ್ ಮಾಡೋದಕ್ಕೆ ಬರಲ್ಲ. ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಫ್ಯಾಕ್ಟರೈಸ್ ಮಾಡೋದ್ ಬಂದಿದ್ರೆ ಇಲ್ಲಿ ನನಗೆ 2 ರೂಟ್ ಸಿಗ್ತಾ ಇತ್ತು. ಅವಾಗ 2 ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಬರ್ತಾ ಇತ್ತು. ಬಟ್ ಇದು ಎಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2 xi omega ns ಪ್ಲಸ್ ಒಮೆಗಾ ಎನ್ ಸ್ಕ್ವೇರ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಫ್ಯಾಕ್ಟರೈಸ್ ಆಗದೆ ಇರೋದ್ರಿಂದ ನಾನು ಇದನ್ನ ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರ್ಕೋಬೇಕು? ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರ್ಕೋಬೇಕು, ಬಿ ಎಸ್ ಪ್ಲಸ್ ಸಿ. ಇಸ್ ಇಟ್ ಓಕೆ? ಫಸ್ಟ್ ನಾ ಏನ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ, ಈಗ ನೀವು ಏನ್ ಲೋಯರ್ ಕ್ಲಾಸಸ್ ಅಲ್ಲಿ ಓದ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದೀರಾ ಆ ಮೆಥಡ್ ಫಾಲೋ ಮಾಡ್ತೀವಿ ಈ ಕೇಸ್ ಅಲ್ಲಿ. ಅಂದ್ರೆ ವಾಟ್ ಈಸ್ ಸಿ ಆಫ್ ಎಸ್? ಸಿ ಆಫ್ ಎಸ್ ಇಸ್ ಎಂಟರ್ ಥಿಂಗ್ ದಿಸ್ ಒಮೆಗಾ ಎನ್ ಸ್ಕ್ವೇರ್ divided by s square plus 2 xi omega ns plus omega n square into 1 by s. Is it okay? Right? ನಾನು ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ, ಇದು ಎರಡನ್ನು ಕೋಯಿಫಿಷಿಯಂಟ್ಸ್ ಕಂಪೇರ್ ಮಾಡ್ತೀನಿ. ಇದು ನಾನು ಎಲ್ ಸಿ ಎಂ ತಗೊಂಡು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ಇದು ಎ ಇಂಟು ದಿಸ್ ಎಸ್ ಸ್ಕ್ವೇರ್ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಬಿ ಎಸ್ ಪ್ಲಸ್ ಸಿ ಇಂಟು ಎಸ್. ಇಸ್ ಇಟ್ ಓಕೆ? ರೈಟ್? ಇಲ್ಲಿ ಎಲ್ ಎಚ್ ಎಸ್ ಅಲ್ಲಿ ಏನ್ ಅವೈಲಬಿಲಿಟಿ ಇರುತ್ತೆ ನೋಡಿ, ಈ ಟರ್ಮ್ ಇಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಬೇಡ. ಈ ಸಿ ಆಫ್ ಎಸ್ ಇಲ್ಲಿ ಇರುತ್ತೆ ಎಲ್ ಎಚ್ ಎಸ್ ಅಲ್ಲಿ. ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಆಕ್ಚುಲಿ ಈ ಡಿನೋಮಿನೇಟರ್ ಟರ್ಮ್ ಮತ್ತೆ ಈ ಡಿನೋಮಿನೇಟರ್ ಟರ್ಮ್ ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಬಹುದು. Now what is left out in LHS? Omega n square is left out. What is left out in RHS? A into s square plus 2 xi omega ns plus omega n square plus s into bs plus c. Next ಇದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀನಿ. ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ I will be equating the coefficients of s square, s and constant. You can have a look. Now I will multiply this, and after comparison of s square, s and constant, what do I get? A plus b is equal to 0. ನೋಡಿ ಇಲ್ಲಿ ಎಲ್ ಎಚ್ ಎಸ್ ಅಲ್ಲಿ ಒಮೆಗಾ ಎನ್ ಸ್ಕ್ವೇರ್ ಮಾತ್ರ ಇದೆ, ಅಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಮಾತ್ರ ಇದೆ, ಎಸ್ ಸ್ಕ್ವೇರ್ ಟರ್ಮ್ ಇಲ್ಲ, ಎಸ್ ಟರ್ಮ್ ಇಲ್ಲ. ನೋಡಿ ಇನ್ನು ಆಲ್ಮೋಸ್ಟ್ ಒಂದು 30-40 ಸೆಕೆಂಡ್ಸ್ ಅಲ್ಲಿ ಲೈಕ್ ಸೆಷನ್ ವೈಂಡ್ ಅಪ್ ಆಗ್ತದೆ. ಇಲ್ಲಿ ತನಕ ಲೈಕ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಕ್ಲಿಯರ್ ಇದ್ರೆ well and good. If not, if you have any queries, you please try to ping me in the WhatsApp. Rest of the things I'll take up in tomorrow first hour class in the college.